Okay, so again, thank you for everyone for coming out tonight. I appreciate it. And help me welcome Mike from the National Weather Service. Thanks, Mike.
Thank you. Good evening, everybody. Let's try that again. Don't you hate when people do that? Good evening, everybody. All right, we've got that taken care of. So welcome tonight. Dan, thank you again for having us at this event. This is certainly a highlight of our spring season as we try to go out doing outreach from the National Weather Service. My name's Mike. I'm morning coordination meteorologist at the Weather Service office in Romeoville. I'm joined by one of our forecasters, Zach Yak, over here. We're going to kind of switch off during the presentation here a little bit. As Dan mentioned, if you've been here before, and who's been here before? Right, most everybody. So this will be a little bit different. A little bit of spotter, a little bit more on the preparedness, and I think the bottom line of what we're trying to achieve tonight is a lot of you who have been here before are probably pretty weather savvy, I'm guessing. So that's good. There's some topics that we haven't covered in spotter training that we're going to talk about, like heat and beach hazards and a few other things. But we're also going to provide you with a little bit of info that we want you to take home, take to work, take to the people that are in your life. They may not be as weather savvy as you are, right? And bring a little bit of this to them. And like Dan said, this is very timely. We've had a very active spring so far. This is kind of like our fourth big severe weather event that we've had. Not so much here locally. So kind of one of the scenarios that we were thinking might kind of play out where it would stay to our southeast kind of has played out. There's some damage down southeast of us in Ford and maybe Iroquois County, maybe over northwest Indiana too, so not far away. So it's one of those days we had pretty good potential, but it was also kind of a complicated situation. So who's familiar with the Weather Service? Probably the same folks who have been here before, right? All right, good. So we're going to talk a little bit about what we do, a little bit more than we typically would in spotter training. It's kind of some of the services we have. Then we're going to talk about different spring and summer type warm season hazards. So heat and air quality, which you may not think much about. Beach safety, we'll get to that one as well. But our focus is going to be on thunderstorms. That's where Zach's going to take over. How thunderstorms work, the different types of storms, some examples of what we see, and then safety. So the planning, the monitoring, the awareness that we're going to hit really hard tonight that we want you to take back to your world and share with the people that you know. And then we're going to wrap up with a recap of a big severe weather event from last year and show you some of the information leading up to it. We probably could have done that for today, but it's hard to forecast that far in advance when we're putting these slides together. So, all right. So about the Weather Service. We've been around since 1870. And what a lot of people may not know is that I think it was the first, if not one of the first, Weather Service offices, used to be called the Weather Bureau back then, part of the Army Signal Corps, actually started here in Chicago. So back in 1870, and we've had a presence in the area since then. And actually the first weather warning, at least government weather warning, probably weather warning of any type, at least in this country, came out pretty soon after 1870 we got started. And that came from the Chicago office, and it was a warning for Lake Michigan. That was the impetus to start the Weather Service. There was some interest that people had on Lake Michigan. There were a lot of storms. There were a lot of people lost. There were a lot of commodities lost at the time. And someone, I believe, from Wisconsin lobbied Congress to try to do something about that. And so that's kind of how government weather forecasting got started in this country. Later on, 100 years later, we became part of NOAA, the National Oceanic and Atmospheric Administration. We've been in a few locations throughout the city and in the suburbs now. We've been in Romeoville since 1991. And we stay busy. We have a lot of a complex forecast area that we have. I'll show you the map of that here in just a second. But the Weather Service as a whole, we've got national centers. You're probably familiar with like the National Hurricane Center or the Storm Prediction Center. We have local offices like ours, one of 122 across the country, as well as U.S. territories. You can see the patchwork of colors that represents the forecast areas of those 122 offices. We also have river forecast centers and other regional centers as well that focus on certain areas. In the River Forecast Center's case, they focus on hydrology and rivers, river engineering, river modeling, river forecasting. So we work with them very closely because our area that is served hydrology-wise is supported by the North Central River Forecast Center, which is outside the Twin Cities in Minnesota. There's one other Weather Service facility that I'm guessing most people here have not heard of, but is actually pretty local to us. Who's heard of the Center Weather Service Unit, CWSU? All right, one person maybe. Okay, a couple people. All right, so that's another part of the Weather Service. If you're familiar with the FAA in the area, they have an air route traffic control facility up in Aurora. And each one of those air traffic control facilities around the country, of which there's 21, has a Center Weather Service unit in it. And that's a crew of 4 meteorologists that are Weather Service employees contracted to the FAA, and they provide 16-hour-a-day, 7-day-a-week support to traffic managers. And those traffic managers are basically figuring out the air traffic patterns in the Chicagoland area. We've got one of the busiest airspaces in the world. It's very weather sensitive on a lot of cases, and it's a big job, and weather plays a huge role in doing that. So we have meteorologists that directly support those decisions. So our mission, to provide weather, water, and climate data for the protection of life and property. The rest of the mission is to enhance the national economy. You think of all the things that weather can affect. Property and life, for sure, that's always number one. We think about things like tornadoes and flooding and blizzards and heat, but also the economic factors, all the things that weather touches, whether it's transportation, agriculture, energy, other industries. Weather is certainly everywhere. You probably know us best for things like severe weather watches, such as we had today, and severe weather warnings. Fortunately, here we dodge those, but not so much down to our southeast, of course. So we issue watches. Like I said, you're probably familiar with those. We also issue, on a regular basis, 7-day forecasts. And that data is actually, that forecast information is available in an hourly frequency out to 7 days for most of our elements, whether it's cloud cover, chance of precipitation, type of precipitation, wind speed, wind direction, humidity, dew point, temperature, all these different things that we forecast all the way out to 7 days, which is available on our website, weather.gov. We'll show you some links later on. Special services for aviation, I kind of mentioned that a little bit with the CWSU. Our office is responsible for providing airport-specific forecasts for 5 airports: Rockford, DuPage Airport, O'Hare, Midway, and Gary airports. And then we coordinate with our counterparts at the CWSU on those forecasts to make sure everything is in alignment. Because weather at the terminals, the airports themselves, affects weather in the airspace and vice versa. We do fire weather information for land management. A lot of prescribed burning has been going on as we get towards green up here in the spring. Talked about some of the hydrology that we do, river forecasts and the like. We provide what we call Decision Support Service, or DSS, to our public safety partners, so emergency management, police, fire, even public works. Any government agency at any level is what we consider a core partner. We work very closely with the broadcast media as well. We're very fortunate to have a really close relationship with all the broadcast meteorologists in the Chicago market as well as the Rockford market. Sometimes we can even go on site to provide this support for those public safety officials. So this picture here is actually down at North Avenue Beach. One of our forecasters with a gentleman from the Chicago OEMC, their Office of Emergency Management Communication, for the Air and Water Show. So weather sensitive, big crowds, lots of weather concern for an event like that. So sometimes we can provide that level of direct support to partners for that purpose. Here's our forecast area. It's 23 counties. We have about 10.5 million people that live in those counties. 18 of those are in Illinois and 5 are in Northwest Indiana. That's the 5th most populated forecast area in the Weather Service. That translates to being busy. So a lot of general public, of course, but also those partner agencies at the municipal level, the county level, the state level. We certainly have lots of partners that we work with. All right, so let's move into a little bit more about the weather then. Kind of a quick quiz. Out of this series of different weather-related hazards, which one do you think, at least on the most regular basis, is the deadliest each year? Just yell it out. Heat, tornado, flood. All right, so some of everything, right? We see most of these. We don't really directly see hurricanes. We can see remnants, though. But on a regular basis, heat is actually the deadliest weather hazard in this country. Now, sometimes it does get surpassed by flooding, depending on the year. So, but we do have to be concerned about pretty much all these weather hazards. But heat is certainly the most deadliest on a regular basis. So let's focus on that, on a national scale here. All right, so again, heat typically kills more people every year than other weather-related hazards. Hot temperatures aren't the only thing that make heat dangerous. We have to worry about the moisture content of the air. Ultimately, we're concerned about the heat's impact on us as humans. So, what does the moisture content do? Well, that helps determine, are we able to release our own heat? Sweat, evaporation, that type of thing. Overnight temperatures are a big factor of what we look at. If it's hot during the day, we really need that recovery at night when it typically cools off to kind of recharge ourselves and to kind of mitigate that heat, the stress of that heat that we saw during that particular day. And then if we have another day of hot and humid temperatures and humid air, we have to do it all over again. So we want that cool overnight temperatures. Now, especially as you get more into the metro area and the urban heat island, that becomes more of a challenge. We don't cool down as much at night. If we don't have access to air conditioning or other cooling options, that heat is going to start to affect us on a cumulative manner. That's how heat works on our bodies. And that's the point about duration. So is it a day or two, or is it several days? And then the time of year. Are we acclimated to the heat? Are we coming out of a cool spring, then all of a sudden, May we hit 95 degrees with a 65-degree dew point or something like that. That can be stressful for us as opposed to kind of having a warmer or maybe hotter summer. Then we get to August and the temperature decides to spike over 100 degrees. We could probably deal with that a little bit better. So a lot of different factors that we're concerned about. Typically in our area, we see 1 to 2 dangerous heat episodes each year, but it does certainly vary. We think back to the 1995 heat wave, which killed several hundred people in this area, kind of a several-day prolonged period. And certainly one of the most deadliest that's occurred. We have different ways that we quantify heat or we message about the heat. We tell people, here's what's happening, here's what you need to know. Probably familiar with heat index, right? Yeah, that's what you're typically using. This is still the basis for the heat information that we put out. And it looks at the air temperature and then the amount of moisture in the air, the humidity level. We come up with a heat index. You may not have heard of wet bulb globe temperature. I think this is a little bit more widely used in kind of for recreational purposes. Some school systems may use this for outdoor activities, kind of determining the impact of heat on students and those attending those sessions. The Chicago Marathon, I know, uses this as a very key parameter in their decision-making about the safety of participants. And it takes into a few more things besides just air temperature and humidity. We look at the wind speed, the sun angle. So is it early in the summer or late in the summer or in the fall? And then how much cloud cover there is. All these kind of affect what our body or how our body responds to the atmosphere outside. We don't currently base our products, which I'll get to in just a second, on that, but that's another emerging tool. And then a new tool as of last year, it's still considered experimental this year as well. It's called the NWS Heat Risk. This was a collaboration between a variety of agencies, and it looks at things like time of year, the duration of the heat, and then the vulnerability. So, are we in the dense urban area or the less dense area, things like that. So it's a 5-category scale. You kind of see the range of possibilities there. Time of year does play a big part of it. So we are more likely to kind of be in these higher levels if we get a few hot days in, say, May versus August. But you're probably going to be hearing more about this product in the coming years, or this piece of information, as we develop it, learn about it, and improve it. So we do issue what we call heat products. So watch, warning, or advisory, we kind of call those products. Heat advisory means we need to pay attention, we need to use caution. It's getting hot, it's getting humid, it's going to start to affect us. And us, that's a wide range of different responses by people. Are you susceptible to heat or more susceptible to heat than someone else? A lot of factors drive that. But we're looking at heat index values between 105 and 110. We typically see these 2 to 4 times a year. So it's not uncommon, but it's certainly something we have to pay attention to. Extreme heat warning. If you pay close attention, these used to be called excessive heat warnings. We've modified the terminology to call it now an extreme heat warning. And these are really the days you have to take precautions. You really have to limit your exposure to the heat and the sunshine in particular, because we're expecting heat index values of 110 or more. Or if we have a situation where we get 4 more days of heat index greater than 105, so again, that duration, that cumulative effect we talked about before. Typically, we see these about once every 1 or 2 years. Again, depending on the year, sometimes you might have 3 or 4, but that's the average, about 1 or 2. And typically, you're going to have an extreme heat watch issued leading up to an extreme heat warning. Now, we put a note in here at the bottom. Keep in mind, heat waves attract thunderstorms. So when we get our heat waves, we might talk about the term like heat dome, or we usually get a ridge of high pressure. So think of a big ridge in the atmosphere if we're looking at a map. That's usually somewhere near us or perhaps over us. And then usually when you have a big ridge, somewhere else you have a big trough. Trough means active weather. We've got a trough through coming now. That's where we're getting the thunderstorms, the precipitation. So sometimes we're well underneath that ridge of high pressure, which means it's going to be hard to get thunderstorms. It's going to be really hot. But a lot of times we're sort of on the edge of it, kind of where that ridge goes to a trough, and that's where we get the action in terms of weather and thunderstorms. A lot of times we're right on that middle area. So sometimes we might be forecasting a pretty hot and humid day, maybe have a heat advisory or an extreme heat warning out, but we're also talking about the possibility of thunderstorms coming down maybe from the north or northwest, especially during the overnight or early part of the day. That may ultimately spoil the heat. So a lot of challenges in trying to forecast things like heat because thunderstorms are usually not too far away in our case. Something to keep in mind. So some precautionary actions that you can take. If there is excessive heat, you got to stay hydrated, water, electrolytes, those types of things. Spend as much time out of the heat as you can. If you have access to air conditioning, that's going to be important. If you don't have AC, maybe can you go to a relative or a friend's house, or maybe there's a cooling center that's been opened near where you live. If you do have to be outside, you got to take breaks, you got to get in the shade, you got to stay hydrated. So the impacts of heat can sneak up on you. We'll get to that in just a second. Check on folks that you know that may be more susceptible to heat stress. Check the back seat. This happens every year. Kids get left in the back of the car, run into the store or whatever. The car heats up very, very quickly if it's left off and the windows are closed. It's a very dangerous situation. And know the symptoms of heat-related illness, which are basically these up here. So pay attention to how you're feeling. If you're starting to get thirsty or dizzy or sweating or nauseous or weakness, you're probably starting to feel the effects. You need to get out of that situation. And then certainly if it gets more severe, you need to call for help or seek help. So things you can pass along. Now, a lot of these graphics, these preparedness of these safety graphics are on our weather.gov/Chicago website, and they're there for your use. So you can share them. We post them on our social media all the time throughout the year. Forward that to your friends and your audience that you have. Now, a lot of times when we get dangerous heat, we also probably have air quality issues. We think about air quality, and we're thinking about pollutants in the air, such as ozone. It could be particulates. The last several summers, we've had wildfire smoke at various levels of the atmosphere, either high up or even down at the ground. So we're affected by those things, right? Might be headaches, might be irritated sinuses or nasal passages, fatigue, difficulty breathing. Again, you probably know if you have some sort of a sensitivity to these things. So we want to make sure we're staying attuned to the air quality forecast. There's the air quality index. Now, we don't produce this. Usually it's like the state, in this case, Illinois EPA, provides this information. We do distribute it for them because we have a dissemination means, things like the weather radio. We'll talk about that later. It goes on our website. We kind of have an audience and a broadcast and a way to get the word out, but they're the experts in the air quality. We're just kind of the messenger about it. But you can see there's categories based on the air quality index when things are good or they get to unhealthy or even hazardous levels. Air quality alerts, again, we do issue these on behalf of the state EPA. If you are in Indiana, that's on behalf of the Indiana Department of Environmental Management. Like I said, in Illinois, it's the Illinois EPA. All right, how many people go to the beach on Lake Michigan? All right, several folks. We're going to talk about beach safety. And this is a pretty typical, probably late summer, early fall type view on the lake, actually. Why are we talking about beach safety? Well, each year there's dozens and dozens of drownings on the Great Lakes. And in our local area, this is probably the most regular and routine killer of folks, unfortunately, that we see on a regular basis locally. People go into the lake, they get into trouble, and unfortunately they may not make it back out. And this could be for a variety of factors. One of those would be what we call rip currents. I'll show you some imagery of those in just a second. Just the fact that there's big waves. There's what we call a short wave period on the Great Lakes compared to something like the ocean, which means the waves come very quickly. So if you're trying to walk out or swim out, a big wave knocks you over, you don't have a lot of time to recover. So people can get into dangerous situations. Many beaches are unguarded. So while one beach that has a guard may be closed, sometimes you walk a few hundred yards down the beach, there's no guard. It's not the same beach. There's no one monitoring. People do what they want to do at that point, and they sometimes get into trouble. We issue beach hazards forecasts, and it's basically a swim risk forecast. So on the low end, we might have a situation where the waves are not typically large or very large. The risk is pretty low in terms of currents or high waves that are going to knock you over. We go up to a moderate. Again, it's getting choppier, it's getting windier. Folks that are more experienced are probably the ones that should be in the water, even if they should be, versus those that aren't, shouldn't be. And then high-risk days, dangerous waves and rip currents are expected, life-threatening possibility for anybody. So we issue beach hazard statements. We have a website over here on the right. And we didn't have an example for this presentation, but you'll start to see this light up as we get towards Memorial Day with color codings all along the shore for all the Great Lakes, actually, in terms of what the risk level is. So rip currents, basically what they are is they're kind of these narrow channels of water that the waves kind of break on the beach, and then some of that water gets pushed back out down below the surface. So we're looking kind of where this area of mud and sand is getting pushed back out into the lake. Then you kind of have this clear area in the middle. Here's another example of that clear area. Rip currents are often located near the shoreline, but they're also near structures like breakwalls or piers. Now, rip currents are survivable if you know what to do and you can stay calm. And there's a process. They call it flip, float, and follow. If you get caught where you're being pulled back away from the shore, flip on your back, try to float on your back while keeping your head above water, and then follow the current until help arrives. In other words, float out a little bit from the beach. You're not going to end up across the lake in Michigan or something like that. It's not, these don't extend that far, maybe a few yards, something like that. Or you can swim parallel to the shore. So if you go to one side or the other, you're going to get out of this current. And then you'll be able to kind of get your footing and get back to the beach. So the key is to know what the threats are that day, should you be in the water in the first place. If you encounter something like this, know what to do so that you're hopefully that better prepared and that much more able to stay calm, and then follow these steps, and you should hopefully be in a safe spot at that point. So one of the biggest things people do is they panic, right? Very understandable. They try to swim back against the current, they get tired, and they run into trouble. Let's not forget about water temperature. It's pretty cold out in the lake now, certainly this time of year. It takes a while for the lake to warm up from even the 40s and the 50s all the way out in May to maybe Memorial Day. We're probably still in the 50s, and then we peak in July and August, where in some years the lake might get up to even 80 degrees. So just kind of depending on the situation. Thunderstorms, they can stir things up, right? So they might bring cooler water down below the surface up to the surface, and that water temperature along the beach that you're trying to swim in might drop very rapidly, 20 or even 30 degrees. So things to keep in mind. We issue more products too. Lake Michigan water temperatures. OMR, NWS Chicago. If you go ahead and search that on your favorite search engine, OMR is just the code for the product for Lake Michigan water temperatures. OMR doesn't mean a whole lot here, right? It doesn't make any sense. But that's what it is, and you can find the daily water temperatures that we send out for a variety of points along the lakeshore. One of the biggest challenges that we have is that a lot of people travel from elsewhere to come to the lake. So most of you are probably familiar with the lake to some extent. We don't live that far from it. You go to it periodically. And a lot of times the folks that get into trouble come from a pretty far distance, go to the beach, and they're not aware of some of these things. So if you have visitors coming, family, relatives, friends coming from far away, they want to go to the beach, pay attention to these things. All right, so we're going to shift gears to thunderstorms. That's going to be the bulk of the rest of what we talk about tonight. And I'm going to turn it over to Zach to take you through that.
Thank you, Mike. All right, let's start talking about I argue, the funnest part of this presentation, thunderstorms. Okay, so looking back, climatologically speaking, all the way back to 1993, we actually get quite a few storms across much of the United States. This map kind of shows here. And in fact, our area usually averages somewhere around 30 to 45 days a year of thunderstorm. You can see we're in that gray shading here. Now, it goes a little bit less as you go further to the north, and obviously Florida is the hot zone for thunderstorms in the summertime. Lived down there for 9 years. I can tell you every day it storms. Almost you set your watch to it. So we do get quite a few storms up here every single year. Now, how do we get thunderstorms? Well, first things first, you need to have 3 basic ingredients. And these 3 basic ingredients are moisture, instability, and some form of lift, or something that will help force the air to rise. This can be a front, this can be a jet streak, basically it's just strong winds aloft, or even some like a cold front or air low pressure like we're dealing with today. So how does this work? Well, when you get these ingredients together, and we'll talk a bit more about how specifically we get them, basically you want, as the air rises, it condenses, it cools, and forms clouds. Well, as those clouds get deeper and more agitated, they start producing rain. And eventually, if you get enough, you can get lightning out of them. If they get tall enough, we have ice particles in the atmosphere that help generate that charge, generate lightning. So basically, that's how that falls, and eventually you get gusty winds out of them. Sometimes you get large hail, depending on the severity of the storm. We'll talk about what makes the storm severe. So like I said, basically you need these 3 ingredients. Well, what is instability? Well, instability is basically the measure of how much different the surface temperatures are from those temperatures aloft, right? So if you want real good instability, you actually want much warmer air at the ground and much colder air, and preferably drier air, above you. So in a day like today, we had, if you notice down south in central Illinois, we had temperatures in the 70s, dew points in the 60s. That's a very warm, humid air mass for this time of year. Above us, we had temperatures well below freezing. So as you can imagine, that makes that air much more unstable. It wants to rise, and well, we got thunderstorms down across much of central Illinois, and in fact, they're still going on and moving into northwest Indiana and Indiana as we speak. The next ingredient you want is moisture. Well, why does that play a role? Well, number one, you need the moisture to get clouds, right? You can't have thunderstorms without clouds. But you also want that moisture to help separate. Moist air is more dense, or less dense rather, than drier air. So basically that less dense air wants to rise. It's more buoyant. Think of like a boat, right? It wants to float. And as it floats, it rises, can help generate lift, help generate thunderstorms. And find that lift, again, that's something just to help kind of kick the storms off, right? It's like how many of you in the morning need a cup of coffee before you're ready to go out the door and get to work for the day? Most of you. The lift is basically a thunderstorm's cup of coffee in the morning to kick it off and get it going. Okay, and I said there's a lot of different ways you can get those. In our area, we usually get fronts and then these jet streams overhead. Today, it's actually a combination of all 3 of these things is what's driving our storms today. So the basic stages of a thunderstorm are pretty simple. So first off, you start with your 3 ingredients. You get what we call an updraft. You maybe see these towering cumulus clouds. They look like little popcorn balls on humid and summer afternoons. Those eventually, they get growing tall enough, they'll form into what we call a mature thunderstorm. Basically, you have the updraft where the warm moist air is being fed in. Then you'll have the downdraft where you have your rain, hail, gusty winds, all the kind of hazardous stuff part of the storm. And eventually what happens is this updraft eventually starts choking off this warm moist air being fed into the storm. The storm weakens, it dissipates, then you get to this dissipation stage, usually with this beautiful anvil kind of just hanging out in the sky, with maybe this little bit of what we call virga, these basically rain falling aloft, just kind of falling out of it. And depending on the storm, this may happen in a span of an hour, this may take 3 hours, 5 hours, sometimes 3 days. It just depends on the setup and what we're talking about. So, now if you guys remember I mentioned we need a 4th ingredient to get storms to be severe. How many of you have heard of the term wind shear before? Okay, quite a few of you are actually, good. So what does wind shear do and why is it important? Well, for starters, wind shear essentially is, by definition, just the change of wind speed in direction with height in the atmosphere. So down at the surface, we tend to have a lot more friction because of buildings, because of the ground. So the winds tend to be a little bit lighter. We start going aloft, the winds get faster. They get stronger, okay? So that change helps generate rolling motions in the atmosphere, helps generate turbulence. So how many of you have flown on a flight before and been rocked by turbulence on a flight before? Okay. A lot of that's generated by wind shear, okay? So when you have wind shear, what does it do to a thunderstorm? Well, it helps tilt that updraft a little bit away from the downdraft. So you look at this picture here, you kind of see how the rain's falling now away from the thunderstorm as opposed to right on top of itself. That helps the storm last longer. So if a storm lasts longer, it has more potential to become severe. It can take advantage of, longer duration. It can cause more hazards. It can infect more people. In most cases, if you don't have wind shear, the storms basically rain themselves out, like I said, within a couple of hours. So the more wind shear you have, the stronger the storm has the potential to be. Okay, so we get thunderstorms quite a bit, but not all of them classify as what we call severe thunderstorms. Now, there are three main things that get to be a thunderstorm to make it severe. Number one, it produces a tornado. It does not matter how strong that tornado is. If it has a tornado, it is a severe thunderstorm. And we will most likely have a warning on it at some point. Okay? So there actually are quite a few different types of tornadoes here. We usually have what we call the weaker ones, which is what we typically see here in northern Illinois and northwest Indiana. These little EF0, EF1s usually cause wind damage, more like, maybe pull some siding off, maybe pull a couple shingles off, down a couple smaller trees, larger branches, that kind of thing. Usually nothing too life-threatening for the most part. You start going up to the stronger area, this EF2, EF3 range, now you're starting to see how outside walls of houses getting blown down, roofs getting ripped off, those large power station towers getting toppled, wind farm equipment getting blown down, that kind of thing. Then if you get up to this violent level, the EF4, EF5, which these are quite rare, actually only less than 1% of all tornadoes actually fall into this category. To this day, we've only had one F5 in our forecast area since 1950, and that was back in 1990 in Plainfield. If anyone was at the talk a couple weeks ago, we talked about that a little bit. But anyway, these basically level your house. Your house is essentially gone. In some more extreme cases, they actually can dig ground scouring. That's what made Plainfield as strong. It actually dug a couple-inch trench out in a cornfield in the west side of Plainfield as it came in. So they can be pretty destructive. Now, how many of you have heard of this EFU before? Okay, one person. This basically just means EF unknown. So what happens sometimes is we get reports that a tornado's on the ground, whether maybe we see something on radar, maybe a spotter calls us and says, hey, we have a tornado out here in this field. We go out, we go to survey it, but it doesn't hit anything. There's no damage. It's hard to rate it. And the EF scale is based on damage. So if it doesn't hit anything, we need a way to classify this tornado. So that's what this means. EFU or EF unknown, it happened, but we don't have a way to rate it based on its damage. So, like I said, the EF scale is based on damage, but it does have a wind speed component to it. So this is basically what the wind speeds generally are for each one of these. So again, your EF0s, as I said before, are usually less than 85 miles per hour. EF1s get in that more 100-mile-an-hour range, and they go up from there. And obviously, when you start talking EF5, you're talking winds well over 200 miles per hour. Okay? Now, aside from the tornadoes, hail can be another factor that can dictate a storm severity. To be severe, hail has to be at least 1 inch in diameter, in other words, about the size of a quarter. Okay? Anything less than that is not considered severe. It can still be deadly or dangerous, but it is not considered to be severe. You usually won't see a warning issued for anything less than 1 inch. Severe winds are also possible, right? What makes this wind severe? Well, basically wind gusts in excess of 60 miles per hour. It also says 58 miles per hour here. That's because that's technically 50 knots, which is what our base of our warnings, what we use in meteorology, are set to. So technically it's 58, but we round it up to 60 in most of our warnings, so just think 60 to make it easy for yourselves. A lot of times we get calls from people saying that they got 60 mile per hour winds. These actually are quite hard to get. And if you actually experience 60 mile an hour winds, usually you're going to have large branches coming down, weaker trees toppled, that kind of thing. So just because you have a really gusty day or have just a storm come through that produces gusty winds, doesn't necessarily mean it's a severe thunderstorm at that time. It just has to hit that 60 mile an hour threshold. Now, this next bullet point doesn't technically make the storm severe, but it obviously is another hazard they can bring with them, and that's flash flooding. So usually that just means that you have flooding that begins usually less than 6 hours. So how many of you any NASCAR fans in here by chance? Okay, a couple people. Okay, if you remember what happened back in 2022, 2023, and last year at the NASCAR race in Chicago, that was a flash flood. It basically inundated the city. I was there both years and got rained out twice. I'm horrible with those. Anyway, it flooded the city. That's basically what we call flash flood. It sets quickly and usually takes several days, a little bit of time to go away. These, again, called torrential downpours or even a dam break or dam failure on a river. Okay? Now, again, a lot of people call us when they hear thunder. Thunder alone does not make a storm severe. Yes, I know sometimes lightning is a very deadly weather phenomenon. We don't issue warnings for lightning, and no, that does not alone make a storm severe. Yes, you should still go inside when there's lightning, but no, it does not make it severe. No, there will never be a warning just on lightning alone. So talking about when do we typically see these severe hazards across our area? Well, we've had severe weather at all times of the year, all months of the year, each and every one of these. But in a typical sense, tornadoes usually occur between April and August. That's because you have a lot more spin in the atmosphere. You have a lot stronger winds aloft, usually with those stronger storm systems that help generate that really good wind shear we need. So April to August, which basically means we're in tornado season. It usually peaks in June, so we're not out of the woods yet, so don't let your guard down. Hail, again, usually kind of April to July. You still want the colder air aloft to help generate those large hailstones. So again, April, usually about July, we start losing a lot of that. After that, damaging winds typically May to August, and then our flash flood seasons usually July and September. We get those really strong warm air masses, corn sweat, all that kind of stuff that help generate the flash flooding. Again, we've had all these all times and all months of the year. So just because it's out of season doesn't necessarily mean we're immune from these happening. Another thing is, when do they typically occur? Well, severe weather typically occurs during the late afternoon, early evening. Think about dinner time. So between 3 and 5 in the afternoons is our typical severe weather time frame. But as you can see on the time chart here, we've had them at all times of the day, as early as 3 o'clock in the morning, and obviously well into the late hours of the overnight as well. It is basically a matter of when they happen, what the environment is, and what the storm system that we're dealing with at that particular time. Some notable tornadoes that we've had at odd times of the year. Naperville from a couple years ago, that happened at 11:02 at night. The Taylorville EF3 tornado, that happened actually in December. So very out of season for us. Coal City, that was another late night one in June. And of course, the Washington EF4, both a late season one happened in November, and then also happened at 10 o'clock in the morning. So definitely out of season and out of the typical time period. So again, just because it doesn't fall within these typical times does not necessarily mean you're out of the woods if we're talking about this type of severe weather. It can still happen if the conditions are favorable. All right, so let's talk about the different types of thunderstorms, okay? The one that most of us see every single day is what we call the single cell or the pulse thunderstorm. These are basically these little splotchy, kind of we call isolated or scattered thunderstorms. They don't usually pose any severe threat, right? There's not a lot of wind shear. The storms usually go up. They last about an hour. They collapse on themselves. Basically just rains out your parade for a little bit, makes it more of a nuisance type of thing. Still have lightning. Usually get some pretty cool looking pictures like this out of them. We start going more wind shear, we start getting into this what we call the multi-cell. These are kind of your ragged line structures. Maybe you got these little, more scattered to widespread thunderstorms, that kind of thing. Can have some severe weather with them, but typically are just usually gusty winds. Nothing really too crazy. When we start talking the squall lines, these are again a more deformed or more organized line of thunderstorms like we saw today downstate. If anyone came and seen us at our table, you kind of saw what was going on down in central Illinois and into Indiana. That's a squall line that was developing and actually was producing some damaging winds as well as some tornadoes as well. Again, have some severe potential, mostly in the form of damaging winds, but can have tornadoes as well. And then we start talking about really severe thunderstorms. We talk about what we call the supercell. Okay, they have that little hook echo look to them, and usually always produce severe weather, whether it be hail, damaging winds, or tornadoes. They're going to produce severe weather. Now, less than 1% of all thunderstorms fall into this supercell category, but they do happen. We've had a couple here, and I'm sure we'll see some more off and on through the spring. So again, if you hear us talk about the word supercell, that basically means we're in for a bad time. So let's talk about the single cell. So here's what they look like on radar. Again, these little pop-up thunderstorms, they're kind of just scattered all over the place. You see this one's kind of falling along a lake breeze boundary coming in off the lake. Not going to hit everywhere, right? So most of you are probably going to be fine. Most of you are probably going to be out of the way, not a big deal. Though if you're underneath one of them, you're probably going to have to go inside and wait this out for about 20, 30 minutes or so. Primary weather threats, if they do become severe, mainly just hail, or we call microburst damaging wind. Basically, it's just a short burst of winds that come out of the thunderstorm as they collapse. That's about it. Flash flooding, if they become stationary or parked on a boundary like this lake breeze here, they can produce flash flooding, but usually they don't. They don't really usually live long enough to really amount to much. And sometimes they can produce what we call cold air funnels and land spouts. Basically, these are essentially like a water spout, but over the land. They're usually weak, little brief spin-ups that happen just because of some air clashing together beneath the thunderstorm. Don't usually produce any damage, and again, don't usually warrant a tornado warning or anything of that sort. The multi-cell, this is, again, going that more squall line type-esque look. You see they're kind of ragged. You see several little cells in there. Usually look kind of junky on radar. They can usually organize into more defined squall lines. We'll talk about that in a little bit. Again, their main threat is damaging winds. You could have some hail with them if you have the cores get strong enough. And again, flash flooding, if they're slow moving, is definitely a threat with these. And on rare occasions, these do produce tornadoes if the environment is correct. Now, we talked about squall lines. This is basically what happens if a multi-cell cluster grows and gets stronger. It forms into what we call a squall line. You can notice here it's basically one long line of thunderstorms. It's harder to discern any individual cells in here. Well, yes, you can pick out a few of them in there, but most of the time it's one long line of storms. The worst is first with squall lines. So basically means you're going to see the wind come first, and then you're going to get the rain, the thunder, and the rest of the storm itself. So usually with this one, you don't want to be messing around with it outside because the winds are going to usually come blowing through before you even start seeing rain or even any lightning. These ones produce usually destructive winds. They can spin up tornadoes. And again, the tricky part about these is they're very hard to get warnings on with tornadoes because they spin up very, very quickly. A lot of times they happen between our radar scans. Our fastest radar scan we have is about 5 minutes, okay? These things can spin up in a matter of about 2 to 3 seconds, okay? We can get warnings on them. We usually try to know the environment's there. We usually put in our severe thunderstorm warnings, hey, heads up, there could be tornadoes. We will put warnings on them once we see the rotation pop up on radar. But there are occasions with these that, again, these tornadoes drop and we don't have a warning yet because the radar hasn't seen it. We can't see it. Okay, so when we're talking about squall lines, this should be your kind of heightened sense to be ready to move very, very quickly to your safe space, and we'll talk more about where to go with that in a little bit. They rarely produce hail. They're usually more, again, usually pretty shallow, so they usually don't have a whole lot of hail potential with them, but they can, especially in their earlier stages. And again, flash flooding is also a concern, especially if they're parked over the same area for any long period of time. So the most severe version of a squall line is a derecho. Who's heard the term derecho before? Okay, lots of you. Who remembers July 15th of last year? That was a derecho. So anyone who went through that, congratulations, you've been through one of these. The most notable one which is the image you're seeing here, is from August 20th of 2020. You can see this thing, poor Iowa had no chance with this. It basically formed, you can see very quickly, into a massive bow and then ripped right across northern Illinois in a matter of hours. So what is the derecho? Well, basically this is a long-lived squall line. I think the threshold for it is it has to produce at least 80-mile-per-hour winds and has to last for like 200 kilometers or something like that. So they usually happen during the summer months, and again, they can produce tornadoes and often do because, again, these are very severe cases of a squall line. Now, finally, the fun thunderstorm, at least I think they're fun, are the supercells. They're defined because they have a rotating updraft. So that updraft is spinning like a top that helps produce what we call a mesocyclone, and then also can help generate tornadoes, okay? They usually have this, again, that kind of 6 hook look to them on radar. And what that hook is, that's usually where your tornado is found. That's usually where you have the winds that are starting to get pulled down to the surface that are spinning. So again, these ones do always produce severe weather, mainly in the form of destructive winds and strong tornadoes. So you're starting to talk about those EF2, EF3, EF4, maybe even EF5 level type tornadoes out of these things. They can be a little bit weaker, but usually they're the more severe types. And of course, you can get large destructive hail. So you're talking like baseball-sized hail or greater out of these things. And then flash flooding if they become stationary or they park over an area for extended periods of time. So again, if you hear something about supercells, again, these are always going to be severe, and you always need to make sure you're paying close attention because these are going to give you a bad time. This is what they look like on radar. So you see the hook there at the bottom. That's usually where the tornado is. And then usually they have a big hail core like this one does on its northern flanks. So they're pretty cool to look at. They produce some really cool pictures, but they are, again, very deadly, very dangerous storms to deal with. All right, so let's go into some thunderstorm safety. So basically, any severe weather plan comes in 4 stages, okay? The first part is to plan, right? To go through, figure out what is it your thresholds are, and what do you need to do to be safe, okay? And those thresholds are going to change for every single person in this room. Some of you may think, okay, I have rain in the forecast, I'm not leaving the house today. Some of you may think, I'm not moving until I hear the warning go off. Neither one's really bad, but you need to have a plan, right? You need to think about what is your thresholds and what is it going to take to get you to move and go into your safe space. Once you have that plan and go through hazards that are hazardous to you, practice them, right? It's like, how many of you in school remember the fire drills you guys used to have when you guys were in school? Most everyone's hand should be in the air. Right? Same thing. You practice them every year. Same kind of thing at home. Practice your severe weather safety plan. We have Severe Weather Preparedness Week, usually in the spring. that's a good time to practice it. Maybe if you haven't had it activated in a while because we've gotten into a drought or in a heat wave, good time to go over it then, that kind of stuff. Repetition, again, is I had a band director when I was in high school. His favorite phrase was practice makes permanent. So practice, 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 and then when this thing actually happens, you're good to go. Then once you get into a storm phase, you want to start monitoring the weather, right? Things change the drop of a hat. We have squall lines. We have tornadoes spin up very quickly. We have things can go from get worse as the storm intensifies over top of you. So make sure you're doing your daily weather check. And of course, we're talking about severe weather. Make sure you're watching and looking for different forms of communication to keep you and your family safe. And of course, when you start getting into the warning phase, start taking action. Know where your safe spaces are. Go to them. Make sure they're ready to go. And again, this is a cycle. This is not a one, you do one and you move on to the next one. You don't touch it again. This is something that you have to do every year, even several times a year, depending on your situation and what happens. So the general storm planning timeline is this. If we start talking about storms a few days out, usually these thunderstorms, because of their smaller and more discrete nature, typically are harder to forecast more than maybe 3 to 4 days in advance. Okay? We start talking about storms a few days out. This is probably your time to go through and start thinking, okay, hey, do I have my supplies ready to go? Did I use up any of my provisions in the last event that we had? Do I know where my safe place is? Did it change? Did I move houses between the last time we had a severe weather event? Maybe I'm renovating part of my basement, or I'm renovating a part of my house. Has my place changed? That kind of thing. And of course, make sure you know that your family's aware that, hey, we need to communicate this kind of stuff, right? If you have kids that are going to be coming home from school that day, may have after-school practices, know how to get in touch with them in case things turn for the worst. We start getting into the day before. This, again, our forecast usually gets pretty good. We can usually narrow it down to about a county, maybe a couple of counties away. Usually know how strong the storms are going to be, what the impacts are going to be. This may we want to start considering adjusting your plan. So let's, again, if you're talking about a day like today, squall lines, possible tornadoes, maybe don't be doing outdoor activities. Maybe find something indoors to do. Make sure your phones are set to receive wireless emergency alerts. These, again, I'll talk about them more in a little bit. Again, they're very useful. They're a good way to get a warning. Make sure your phone has those turned on. And again, I can't stress this one enough. Make sure your shelter is clean and ready to go. I can tell you how many times I've seen people tell me that, oh, they never forgot to clean up their storm shelter. Then when the warning comes out, they're diving through a pile of rubble trying to get to safety. You don't want to injure yourself trying to duck for cover, okay? My grandparents were notorious for not cleaning out their storm shelters. I cannot tell you the amount of times I've had to yell at them about that. So again, make sure your shelter's clean, ready to go. And then when you get to the day of, this is, again, that time to remind your family in the morning over breakfast, hey, storms are in the forecast today. They're probably going to be severe. I need you to text me after you get out of school. Or, hey, make sure you do this when you come straight home. Turn on the TV, be checking weather, that kind of thing. Know how to evacuate or get to your safe place if you have to, right? So if you're in an unfamiliar place, know where you may have to go. If you have to go out to the store, make sure you know where the store's safe place is, that kind of thing. And of course, if the warning is issued, you may only have seconds to act. So again, make sure you know where you got to go and get there as soon as humanly possible. All right, I'm sure most of you probably have seen the SPC risks before, right? Most everybody here. Okay, just a quick review on these. I won't harp too much on them. Basically, they're designed to kind of tell you a little bit about the severity we're expecting and the coverage of severe storms we're expecting. So the most common one we get around here, we usually get this about 35, sometimes even 40 times a year, the marginal risk. This basically means that not every storm is going to be severe, but a few of them could be. Your threats are mainly again, gusty winds, hail, that kind of thing, typically for us. But again, every storm is going to be severe. Not everybody's going to be in a severe weather scenario. It just means there could be some stronger storms to deal with. We get to the slight risk. We go up to a category. This is that level 2 out of 5, the yellow shading. This is usually for us about 15 times a year. So they're fairly common for us, especially during the summer months. And this actually for us is when we get most of our severe weather days, okay? So start thinking about that. You start hearing the slight risk, that's maybe your key that, hey, we may actually have a bad time to deal with here, okay? We're talking about more broader coverage, more of a scattered coverage of severe thunderstorms, right? So again, still not everybody's going to get one, but most of you will probably see something in the form of severe weather, whether it be damaging winds, hail, maybe tornadoes, something along those lines. Okay, we start talking about the enhanced risk. This, again, widespread severe storms, like we saw today, squall line type thing, maybe some supercells. We typically do these a couple times a year. We've already had, I think, 3 this year already, so we're already overachieving this, and it's only April. We'll see what happens the rest of the season. So again, if we start talking enhanced, that's usually about as high as we get throughout the course of a year in most years. So that should be your kind of your key that, hey, this is a bad time. I need to be taking this very, very seriously. If we get into these other ones, so the moderate risk at level 4 to 5, that basically means severe weather outbreak. So think like March 31st, the July 15th derecho. Basically, that's what we're expecting. If we're talking the moderate risk, about 1 every 2 years on average for us. And then if we get the high risk, this basically means deadly tornado outbreak. I don't know if anyone remembers April 27th, 2011, that outbreak that went through Alabama. Think that if you see us under a high risk. Numerous tornadoes, some of them are going to be on that strong side, pushing EF3 to EF4 intensity likely. We get about one of those once every 5 to 10 years. So that's your day to basically be like, okay, we're in trouble. Okay, but again, if you're prepared, you will be fine. Okay, now, if you look at the SPC outlook, that's a great way to get a tool. Now, there's also some other ways to do it as well. Most of this outlooks, again, they're pretty broad. They cover a lot of states. Their discussions are very, very technical, so unless you have a meteorology degree, you're probably not going to understand a word they're saying. But we take them and kind of break it down more into these weather stories. Okay, we take the threat, we highlight the map for you, show which parts of our area are in which threat category, and what hazards we're expecting, when they're going to occur, what the destruction is going to be, and again, storm motion, all that kind of fun stuff is all on there as well. So again, weather.gov/Chicago is where all that can be found. We also have the hazardous weather outlook. This is basically a text product that highlights any severe weather that we're expecting, whether it be from beach hazards, heat, thunderstorms. It's all in there. Always has the storm motion in there as well, so if you're curious how fast storms are going to be moving, you can check it out there. And there's also a graphical version online as well that, again, kind of reflects the graphics you kind of see here. You also can always check our forecast at NWS weather.gov/Chicago. Again, get an idea of several days out, what we have coming down the pipe, and whether or not you need to be concerned about it. Because again, that's the question you should ask yourself every single day is, what is the weather going to do, and do I need to be concerned about it? I'd argue 9 times out of 10, the answer is you're probably going to be okay. But we start talking about severe weather, the answer is probably going to be I need to pay attention. Now, once we start getting storms on the scope, ask yourself, what's the best way to monitor this situation? Because that's going to change, right? Let's say you're at home, maybe turning on the TV. If you're out and about at an event, that may be checking social media on your cell phone, that may be checking our website, maybe looking at radar yourself if you have a way to do that. We do post, again, these what we call graphical nowcasts or GNows. Basically, they're little couple-hour long graphics that kind of showcase where storms are, where they're moving to, and what the threats are going to be the next maybe 2 to 3 hours. And then, of course, there's always the watches, which a lot of people know about, and again, are highlights that, again, you could have some dangerous weather in the next couple of hours. Now, the thing about watches to kind of keep in mind is not every event's going to warrant a watch. The marginal and those slight risk days, the storm coverage is usually pretty sparse, okay? So they may not put out a watch because it typically requires us to have about a 50% confidence that we're going to see severe weather. In those days, sometimes that confidence is a little under that. So there may not be a watch on those marginal and slight risk days, but you could, again, if you're in one of those storms, you could definitely get severe weather. So don't always wait on a watch to be issued. Yes, on the bigger days like today, like a derecho type event from last year, a March 31st type event, we will usually have a watch that comes out early in the afternoon, or maybe even as early as the morning hours, depending on the situation. But again, not every event's going to have a watch, so don't wait on a watch. Be looking at the weather ahead of time so you know what's going on in case storms get active. All right, most of you, I'm hoping, know the difference between a watch and a warning. But if you don't, the watch, again, just means to be alert that storms and the conditions are becoming more favorable to produce severe weather, whether it be damaging winds, hail, tornadoes, what have you. But they have not formed yet. So basically means they're not on the ground, they're not happening, but conditions are getting close. We could be looking at storms here very shortly. Once the warnings come out, that's your signal to take action. So basically means a severe storm or tornado has been spotted by a spotter. We're seeing it on radar. So basically means take action and go seek shelter in your safe place. And make sure you have more than one way, at least 2, preferably even 3 is better, ways to get warnings, because as we know, sometimes one system may fail. And the last thing you want to do is be not aware that there's a warning for your area. So how can you get a warning? Well, there's a lot of good ways. There's a NOAA weather radio, which I can already tell there's a couple of them up here that some of you are going to win tonight. So there's a couple of those. Also, your local TV and radio stations, that's another good way. Again, those wireless emergency alerts. Internet sites, whether our website, your favorite TV website, they all those have good things. And of course, your friends and coworkers and neighbors, those are always good people too that are weather aware. And you can be one of those people for your friends and your family. Now, there are also outdoor sirens. I brought that one up last for this reason here because I can at times we get asked, why do we set off the sirens? We don't set off the sirens. These are controlled by the local cities and local counties, and they discern them at their needs, okay? Every county is different, every city is different, okay? Some of them use them for severe thunderstorm warnings, some use them for tornado warnings, some use them for other civil defense needs. Some even use them as alerts to warn the fire department to get to their fire stations because they have a big call coming up or something's going on. Every county, every community is different. So if you want to know more about that, I highly suggest looking it up on your county's or city's website. And they may have something out there or contacting them about what their thresholds are. But the other thing is they are used for outdoor purposes only, okay? Yes, if you live under one or close to one, you may hear it inside your house. Not everyone's going to. If you live out in the sticks, you're not going to hear one of these things. I promise you that much. So don't wait on one. And they usually, again, are a signal for you to go seek additional information. Because, again, their uses are different for every community. So if you hear one, that's your signal to go look, whether it be on your phone, TV, somewhere to go find out what's going on and take proper action. Again, before we do not set them off. That is a county thing. So please check in with them. And then also, if the siren stops sounding for whatever reason, some counties set them off at very short bursts, just as an initial thing. Some do it the whole duration. If the siren stops, it does not mean the threat is over. In some cases, it's because power gets knocked out to them. It's because they've been toppled over. It depends on the situation. So just because the siren stops does not mean the threat's over. Have another way to receive a warning information while you're in your shelter. Whether it be a weather radio, your phone, something. So you know when the threat's ended, you can come out of your sheltering location. Okay. So, as I said before, you don't necessarily need severe weather for a storm to be dangerous. Lightning kills numerous people every year. In fact, most people, the reason they get killed is because they go outside too soon after a storm has passed or wait too long to go seek shelter inside because they want to get one more thing at the barbecue. They want to just hang outside for one more second to watch the storm coming in, what the case may be. So all thunderstorms do produce lightning, hence why they're called thunderstorms. To get lightning, get thunder, you need to produce lightning. And a lot of times people always say, well, most thunderstorms will have gusty winds and hail, and they may not be severe. Well, that's true. They do. And sometimes, again, that can still cause damage. That can still cause injuries, and sometimes in severe cases, fatalities from tree branches falling on people. So again, just because a storm happens does not seem to be severe for you to be able to take shelter and should go inside and seek proper safety. And I don't want to ever hear anybody ever say this. It can't happen to me. Oh, yes, it can. It's just a matter of time that it hasn't. So be thankful that it hasn't hit you yet. In case anyone wonders what lightning can do, okay, it's not going to play. Oh, your laptop's right here. Just in case anyone's curious what lightning can do. There's no audio for this. Yeah. So that's what it can do to a tree. Imagine what it can do to you, kind of thing. I've almost been struck by lightning on 3 separate occasions. It's not a fun experience. I will promise you that much right now. Scares the crap out of you. So again, don't be like me. Go seek shelter. Okay? Do as I say, not as I do. Okay, so when you hear thunder, that's your cue to move indoors or into a solid framed car, basically an enclosed vehicle, something like a van, hardtop car, truck. All that works. Don't wait for the rain to start again. Lightning can strike up to 10 miles away from its parent thunderstorm. So a lot of times you're close to hear thunder, you can be struck by lightning. And again, once the storm has passed, wait about 15 to 20 minutes before heading back outside to make sure that storm is well away from you, so that way you're no longer in the strike zone to get hit by lightning on the backside of a thunderstorm. When a severe thunderstorm warning is issued, in most cases, just go inside, get away from the windows, and you can still keep going what you're doing. You can still play video games, you can still watch TV, you can still play a board game, whatever going on at the time. Just move indoors, get away from the windows, you'll most time be fine. Now, if you get the WIA alert for severe thunderstorms, now we have those now, and they trigger for 80-mile-per-hour winds and baseball-sized hail. In other words, basically hail of 2.75 inches in diameter. If you hear that go off treat it like a tornado warning. Go to your basement, go to the interior room, because basically it means we're talking tornado-like damage possible from those type of severe thunderstorms, okay? Now, obviously, when a tornado warning is issued, stop what you're doing, move to an interior room, go to, or a basement, and wait until the storm has passed to come back out. Now, why do we say severe thunderstorm warnings are so severe, and why did we upgrade to this next category? Well, in a lot of cases, damaging winds can be just as deadly. A lot of people, again, don't take severe thunderstorm warnings as seriously as they take tornado warnings. And so people were just kind of hanging out at home, doing their normal thing, and trees would come down in these gustier type setups. So we put in that next thing to kind of help give people that sense of, hey, this is not your typical severe thunderstorm, this is not your typical thunderstorm, you need to be seeking shelter. And this is a good video kind of showing how fast things can deteriorate with these type of damaging windstorms as they come through. And there's some audio here. So again, not much going on, getting a little bit breezy. And we're getting stronger. Part of a tree blew by. Probably some shingles flying in here. I don't know what that was that just bounced by. So you guys can see how fast that blew up, right? So again, if you're outside in that, not probably going to be a good day for you. You're probably going to get hit with whatever flying debris just flew around. You know, these trees could come down on top of you. And of course, if there's hail in these things, wind-driven hail actually can cause quite a bit of damage. Actually, there was quite a bit of hail. You can see the ground here. It's small hail, but it basically the equivalent of getting hit with a hail at 80 miles an hour feels like getting hit with a shotgun blast. Not a fun experience. So again, wind-driven hail is nasty. So again, if we're talking about those WIA-type thunderstorm warnings, get inside, get to the lowest floor. Treat them like a tornado warning. And it froze up on me. I don't want to watch it. There we go. Okay, so from that same storm, this is what kind of damage it caused. Notice here we have looks like a piece of a tree branch that got impaled through another tree. We had a barn that got shoved off its foundation, and several large trees toppled onto homes. Now, to most of you, that may look like tornado damage, right? That was straight line winds. So this is a good reminder that the winds don't have to be spinning to cause severe damage, hence why we have those WIA-type warnings. And then when they're issued, you need to take them seriously because this is what can happen even if the winds are not spinning. Okay, so good segment to the wireless emergency alerts. Again, these are on your cell phones. Most of them are turned on by default, but if you somehow have turned them off, you go to your settings, usually have something in there called emergency alerts or emergency systems or whatever, depending on the phone and what you have. Basically go in there and there should be a button that says wireless emergency alerts or WIA. Make sure it's turned on. It's very easy to do, and again, keep it enabled at all times, especially during severe weather, because it can save your life. It will wake you up in the middle of the night, which is really important. And again, gives you a heads up for tornado warnings, those destructive severe thunderstorm warnings, and of course, life-threatening flash flooding that you need to be taking seriously and moving the higher ground for. These all will activate that wireless emergency alert. Okay, most of you probably know where to shelter for a tornado. We've kind of already covered that a little bit, but just as some good reminders, again, open large rooms are not a good idea. So things like a gymnasium, an auditorium like we're sitting in right now, not a good place to be during a tornado. These roofs come off very, very easily, and then you're exposed to the elements. Obviously, vehicles are not safe. Manufactured or mobile homes, those are also not safe. So if you live in one of those, make sure you're talking to the family that day and try to find a buddy to go stay with for a couple hours when storms are in the forecast. And of course, the best options are, again, anything like a FEMA safe room, basements, in most interior rooms on the lowest floor, all that kind of stuff. Again, just a diagram here. Again, your basement, anywhere in a basement is good to be. An interior room away from windows and outside walls is another good place. And of course, don't be anywhere there's a window, and don't be in your attic when tornadoes threaten, because those are the first things to get torn off the house. Now, at night, we do sometimes get some nocturnal severe weather events, especially this time of year because we are in the spring. Sun sets a little earlier. Some of you may be in bed a little earlier. Make sure you have ways to set things that will wake you up. No weather radios. Good. They will wake you up. They're loud. They're actually obnoxiously loud. Your wireless emergency alerts on your cell phone, those will go off. Most weather apps, I think some of them will tone alert you. I don't know how good they are at waking you up, but they will tone alert. It's another good option. And of course, when you're in your room, make sure you know where your stuff is. Make sure you have a flashlight handy in case the power goes out. Make sure you have your shoes ready to go so you can put them on fast and get to the basement or wherever you got to go. And again, know where your safe place is, because if you wake up in the middle of the night, you're usually dazed, usually kind of groggy. You may not be thinking straight. The last thing you want to do is walk into a wall trying to get to shelter. So make sure you know what you're doing. Make sure you have everything set up and ready to go. Anything out of the way so you don't trip over it on your way out the door, and you're ready to go. Now, if you're at a public building, make sure you know where the sheltered spots are. Most of the time, they're marked with these placards that say tornado shelter here. They're usually posted pretty evenly. Go find them. Again, if you're somewhere that you own a building, or again, are a school official, make sure you train on these things with your employees. Make sure they know where to go so they can help move patrons into these locations if they need to. And again, keep your disaster supplies in those areas or nearby. Make sure, again, first aid kits, some safety provisions, food, water, medical supplies, that kind of thing. Make sure you keep those near the shelters so that way you can access them quickly once the storm has passed. Now, if you're driving in a car, the best thing to do is go find a sturdy building to get into, whether this be a gas station, a local community center, library, and like that. That's the best place to go. If you can't get to one of those in time, or the tornado is between you and your nearest one of those, then you want to lay down as flat as you can in a ditch outside of your vehicle. Okay, basically lower your profile as much as you can to avoid getting hit by debris. Now, the last place you want to go is underneath an overpass. And a lot of people may say, well, we've seen videos of this happening out in Oklahoma. Yes, you have. It's a bad idea. Number one, that acts like a wind tunnel. That accelerates the wind and anything the wind's in it underneath that overpass. So whether it be 2x4s, shingles, a car, all comes underneath the overpass a lot faster than it would be if you're out in an open field. And basically, if you're standing in the way, you just became that object's next target. So again, avoid overpasses if you can. If you can't get to a sturdy building, lie down flat and hope for the best. And in case you're curious what kind of damage a tornado can cause and how hard they can be and dangerous it can be to drive through, this is actually a video taken by a storm spotter who was driving during the Naperville EF3 tornado. And this is kind of what it looked like to him that night. And this was a tornado that was rain wrapped, so you really can't see it. But you notice, low visibility, can't see other cars in front of you. And you can see how bad things kind of get here, how quick they go. You lose power. You really can't see anything. And if you watch, you'll watch this road sign here get blown away toward the middle part of the video here. So, again, you have some other cars trying to drive by. He's struggling, like, oh, get out. Again, you really can't see anything. You can't even see the road lines here. You really can't see if there's any trees down. And the tornado's at this point is kind of right about here, I think, crossing the highway, or getting close to crossing the highway. So again, you really can't see what's in front of you. You really don't know where it is. So again, you can get further into its core, get lofted. And you kind of see where he's at. He's just outside of the damaged swath here. And again, if you keep watching the sign over here, it's going to get sent into outer space here. Oh. But basically, that sign is this one right here. It got thrown several miles away into a nearby field from that tornado. So again, if that was to come flying through your car window, that could be into you, and then that's not a good time. So again, make sure you go find a sturdy place. Now, flooding and flash flooding. Again, these are typically found for us late in the summertime. These usually, for the most part, in our area aren't severe enough to really warrant you to take much of action outside of just getting inside and getting away from the floodwaters. But the difference between the two is basically the time that they happen. Flash flooding, it means rapid, so think minutes to hours of onset. Other flooding is typically more gradual. Think like river rises during the springtime when you have heavy rain. Maybe flooding due to snow melt, river ice melt, that kind of thing. Flash flooding is mainly due to thunderstorms, that kind of thing. Dam breaks, things that maybe are a little more serious, a little bit quicker. Now, for the flood products we do have flood watches. These usually, again, issued hours to maybe even days before flooding is expected to be happening. And again, that's kind of the same thing as a severe thunderstorm or tornado watch. Conditions are becoming more favorable for that. So keep an eye out for those. Flood advisories, these are issued, again, where the more nuisance type of flooding is happening, like ponding on roadways, maybe flooding of fields, that kind of thing. Not a big concern if you're, again, just being safe. Usually that's about 3 to 6 hours, mostly. Flood warnings are issued, again, and flash flood warnings are issued, again, when you're talking about river rises or those flooding events that, again, are going to pose a threat to life and property. So the flood warnings are issued for things like flooded roads, flooded basements, river flooding, that kind of thing. Typically last 12 to 24 hours in duration, but can go much longer than that depending on if we're talking like river flooding. Then of course flash flooding, kind of the same thing as the flood advisories, typically 3 to 6 hours, but again, basement flooding, road, interstate flooding, closures, that kind of thing. Rapid river rises, stuff like that. So again, in most situations, you guys probably won't have to do much in our area. Again, just get inside, just monitor your basement for any flooding in your basement, that kind of thing. If you do live in a flood-prone area, maybe move to higher ground, go visit a friend for a couple hours, that kind of thing. But if a flash flood emergency is issued, this basically means that we're seeing life-threatening flooding. Basically, it means we're seeing, roads getting washed out, tunnels getting inundated with water, that kind of thing. So if you hear this go off, don't drive through any flooded roadways because they could be washed out. And again, if you're in a floodplain, basically it means you need to leave and go to higher ground immediately. The last time this kind of thing happened, think like Hurricane Katrina type flooding, Hurricane Helene, or even the 1996 Chicago flash flood. Those are conditions that would warrant a flash flood emergency. And again, think of when you would actually need to go take action. Otherwise, you're probably going to be okay just staying home and doing your typical, typical thunderstorm safety would suffice. And just a quick reminder, again, why you don't drive through flooded roadways. And I always see the guys in pickup trucks that do this. So you can see, water gets pretty deep. You really can't see the road there. So there you go, 12 inches of water basically will pick up a car, and 18 to 24 will move a large vehicle, and then he's just along for the ride. Hate to break it to you, none of our cars are amphibious, in case anyone hasn't figured that out yet. I wish they were, but they're not. And again, roads can wash out. You see these pictures here? These are actually from areas where roads were washed out due to flooding. So again, if you're driving through a floodwater, you could drive into this and, bad news bears. So again, turn around, don't drown, don't drive through flooded roads. Again, I already talked about this. 6 inches of water can move a person off their feet with ease. 12 inches can move a small car, and 18 to 24 can move large trucks and SUVs without even thinking. All right, so let's walk through really quickly an event to kind of show you guys how our messaging kind of ramps up going through one of these. So I'm sure most of you remember the derecho from last year we already talked about. So this event, again, was on a Monday. So we start seeing 7 days out, or 5 days out in this case, that we actually had a chance for thunderstorms that day. Again, look at this. Look at the heat wave we're kind of experiencing at that time. So remember Mike said the heat waves usually bring severe weather? Well, there's your case in point right there. So again, severe weather possible that day. We start getting closer. We start noticing we're getting into a more humid and muggy pattern. This kind of graphic comes out. We may talk about multiple clusters of storms. Could be severe. Flash flooding also possible. There's the hot and humid conditions that, again, Sunday into Monday. We're maybe still uncertain on some timing and coverage. And any storms, again, how severe they may get may depend on, cooling, where the front is, how fast things move through, that kind of thing. Now, let's watch the SPC outlook. So at day 4, they put us in the kind of the slight risk area here. They kind of shifted up a little bit further north. That's probably because that ridge was building, kind of shunting things more to the north, as much as we usually are on the border of these things. We get into the day 2. You start getting the broader, more standard risks. And then we get to the day before. Now they put an enhanced risk. Now we're pretty confident something's going to form and be pretty bad. And then they actually did put out a moderate risk the day of the storm. I think this came out, let's see, this was issued, they issued this one at 20Z, which is 3 o'clock in the afternoon that got issued. So again, things ramped up pretty quickly that afternoon. And you see how much bigger the enhanced area got too. So again, pretty quick that we knew we were on to some severe weather that day. Again, locally taking that moderate risk graphic, so basically you see it's most of our areas within it. Everywhere that's not in the red is still within that enhanced risk. So as we talked about before, those again are our higher end severe weather days, meaning we're probably going to get slammed. Again, dangerous sign of moving storms. There's your timing, 6 to 3 in the morning. what to expect, the line of damaging winds, several tornadoes. Some of them could even be stronger tornadoes. And then again, there's your storm speed at 40 miles per hour, 40 to 45 miles per hour. So again, a lot of good information here that if you read the graphics, you can get and be mindful of. All right. Start going into that event. The watch, the Severe Weather Storm watch came out. Let's see, this came out at 3:20 in the afternoon. Include our western counties here. Then they all got upgraded to a tornado watch a couple hours later when we started seeing that the threat for tornadoes was becoming more prominent. Again, we start talking about the storm timeline. This is, again, that GNOW, that graphical nowcast type of messaging. Again, starting the timing of storms, so 6 to 8 here in the Rockford area, 7 to 9 here in the metro, 8 to 10 in northwest Indiana and points east. Again, a lot of good information here to learn about the strong tornadoes, tornado-like wind speeds, and again, those fast storm motions, almost 50 miles an hour. Another GNOW, again, this is when storms were ongoing. They basically were sitting kind of right in this area here. We saw, again, the flash flooding potential had kind of ramped up a little bit with these storms. There were some spots that were kind of training a little bit. That flood potential picked up. Again, destructive winds, several tornadoes. A lot of good information here on the graphic. And here's what the radar looked like that night. Some of you may remember this. So again, a lot of severe thunderstorm warnings. And if you watch the velocity data over here on the right-hand side, when this re-loops through, watch how many of these little couplets, I'll point them out to you, how many of these spun up. So let's let this play all the way through. So I'll start watching. So there's one there, one there, one there, one there, one there, one there, one there. This whole line basically became a line of spinning tornadoes. So again, ramps up pretty quickly going through that. 32 tornadoes came out of this event, most again on that weaker side. We did have one EF2. And then, of course, lots of swaths of 80 to 90 mile per hour winds in there as well. So again, all in all, pretty damaging event. But as you saw, lots of good ways to get that information ahead of time. So again, if you want to find us, this is a great way to do it. Weather.gov/Chicago. Our social media accounts there on X and Twitter and Facebook, to search at NWS Chicago. And of course, there's our Storm Spotter website and again, our email account right there. So I can take a picture of this slide, go right on ahead. Great way to get all the information from us going forward. And I believe that's all I have to talk about here. So what we're going to toss it back over to the five folks here at New Lenox to do the raffling and handout. Now, if anyone here has any questions for Mike or I, we will be hanging out, so feel free to come up and talk to us about your weather concerns, anything about the presentation. But otherwise, thank you all for coming out tonight. Thank you for enduring the weather. Oh, he has a Frisbee. Sort of.
All right, again, I want to say great job, guys. I'm so happy that you did this presentation this year. It was excellent. One more round of applause for these guys. Thank you. I'm going to ask Jacob, and I want to thank Jacob. He's up in the booth up there, but he's handled all of our AV needs. Jacob, can you turn up the house lights?